Okay, good morning. Let's get started slowly, okay? So today is the last lecture in our course. Next week will be your final presentation, and we will have a wrap up, right? Okay. You should have more time to cover this business analytic for you, because this is really a very, very broad area that we can explore, especially when we need to start with some very fundamental things like we need to teach basic programming in the beginning, right? Okay, then there are some statistics things, and we need to put everything together, and most importantly, we want to bring in the business logic, right? The sense of business, the logics of business into, but after all, what the programming that we learned, the statistics method, analytic method, visualization tool that we use, they are only tools, right? They are not our purpose. So what is our purpose of business analytics? We are doing this, right? We want to know, we want to set our strategy. We want to have our focus, have our goal, right? How do we do that? We explore our data, right? When you first get the data, we have some summarized statistics, descriptive statistics. We have some interactive visualization to help us understand our current situation better. Wait a second, let me make sure that I have to do the recording. So the first things of analytic, I would say that the first half of analytic is like exploration, right? You look into the data, try to find the insight, try to find the insight that is not easy to realize. When you have too many data, you somehow do not have an idea, you do not have a holistic idea, a systematic idea of your current business situation, right? That's why we want to do exploration, explorative data analysis, and that would help us set our strategy, right? That is the first half of the course. But the strategy will not realize itself, right? I set the strategy, I want to increase my revenue. I want to focus on this group of a customer. I want to increase their repurchase probability. Right? That is the strategy, but the strategy will not realize itself unless you do something, right? You need to do some campaign. You want to do some marketing. You use some marketing instrument, apply that instrument and some of the customer, right? And expect that their buying amount would improve, their probability of purchase would increase, right? That's what you need. You need to have some tactics. It's not only strategy, right? So now, as long as you want to do the tactics, you need to design the detail and implement the detail, right? You want to design your marketing instrument. For example, if we want to use coupon, how much dollar, what is the face value of a coupon, right? If I want to use like keyword advertisement, right? Which keyword should I choose? How much money should I spend on the keyword advertisement? To which customer group should I deploy that advertisement? That type of decision you need to make, right? You need to choose the instrument, design the instrument. You need to choose your target audience, right? And then you need to evaluate, right? When I apply such an instrument to such a group, what is the expected outcome, right? That is what we are learning in the second half of the course, right? So you're about to wrapping up, right? In order to do this, first of all, we need to do prediction, right? Basically, this is what we are doing now, right? We use data to build model, right? And from the model, we can predict the probability of repurchasement, right? We can predict the expected buying amount for every customer, right? But that is prediction. It is almost the same as, if you still remember, when we do the predictive analysis, predictive modeling for the diabetics patients, right? You know the probability of poor care for each of the patients, right? But if you do nothing, that prediction will do you no good at all, right? See, so the reason that you want to do the prediction is you want to design and apply some marketing instrument on this customer, right? In order to improve your expected outcome, right? That is what we're going to do today, okay? And that is the last piece of the puzzle, if you can see here. This is the last things of the puzzle that we are going to do today, right? The prediction is not enough, right? We need to do some assumption. Specifically, we do not know the cost effectiveness of the instrument yet, right? In the real situation, you will have some data to evaluate the cost effectiveness of each of these instruments. But now we do not have the data and we do not have the time to do that, right? So I will teach you how to use assumption, right? To and incorporate with the prediction and use simulation skill, right? To do the things, okay? The basic logic is something like this, right? This is what we already done, okay? We have data and we build a model, right? With this model, we have PI. The subscript I stand for customer, right? So we know the buying probability of each of our existing customer. We know the expected buying amount of each of our existing customer, right? But and we want to do marketing on them, right? So for every marketing instrument, be that you're sending gift, you're sending coupon, you're doing advertisement, you're doing event, you're doing discount whatsoever, right? It costs you some money, right? Okay. The reason that you spend that cost is because that you wish to improve the probability. You wish to improve the buying amount, isn't it? Right? So, so if we know the improvement, right? If we know the improvement, then we know that the customer's buying probability, the customer I's buying probability will increase from PI to PI prom, right? And if we know the delta, right, then we will know PI prom and NI prom, right? Now, as long as we know that, we can easily calculate this, right? The revenue increment would be PI prom, NI prom minus this one, right? Because revenue is simply the probability times by the amount, right? So before the instrument, after the instrument, right? Okay, but revenue is not profit, right? You need to multiply the margin your margin rate. Usually, you get this information from your accounting department, right? Your accounting department will tell you what is the average margin rate, right? So you got this profit increment, right? But the profit increment need to deduct the cost, right, to get the net effect of the instrument, right? So with that, you get the pi I, which is the expected net payoff if you apply instrument to customer I, right? So and then you can right, collect all of the customers that have positive expected value and sum them up. It would be the total expected profit, right? So this is basically what we are going to do today. Do you have any question? This is what we have done, right? Let me do it again. This is what we have done, okay? Then we need to, we want to do some assumption, right? So we know that if I put on the instrument and I would know the increment on probability and find the mark, okay? And with these things, we can simulate the situation, right? But there's a problem here, right? How do I know the delta P and delta M, right? We are doing assumption, okay? The assumption has to be reasonable, and the assumption has to be flexible enough, right? Otherwise, it would be very difficult to do programming, right? Yes?
Because delta P would be Pi dash minus Pi.
Sorry?
Delta Pi is the difference between Pi and Pi dash.
Yes. Pi plum.
Sorry, Pi?
This is called Pi plum.
Yeah.
Okay, Pi plum. It is the difference. It's the increment on the buying probability, right? Okay. Of course, the higher cost you spend, let's say it's a coupon, right? For the simplicity, let's say that our instrument is a coupon. Now, if you spend a 10 NT dollar coupon, it might not be very useful, right? Okay. If I increase the face value to like $30, maybe it would be attractive to some young population, right? But for the working customers, they might not be very attractive at all, right? So as you increase the C, the delta P will increase with it, right? We know that it's reasonable that way, but we do not know how exactly the relationship between delta P and C is. So we need to do some flexible, parameterized assumption so that after we write the program, we can adjust the parameter, to reflect the difference instrument after instrument, right? That's basically what we are going to do today, okay? See that? Okay. So let's go to our material. Now again, we have two files, right? The PowerPoint file that I'm used, that I have shown you, and second thing is like a zip file, right? So you unzip the file, you again get a folder, right? This is behind the folder. You have some RMD, and basically we are going to start with the TF7 EN. Okay, there are TF7, TF7A, TF7B. Okay, so we are going to start with TF7. Okay. Now in the beginning, we load the data, load the package, and then we take a look at the data. Okay. Now, as I say, we already have the buying probability, and we already have the expected buying amount for each of the customer, right? Each of the existing customer. Where is it? It's in the, let's do that. Set this as working directory. Then let's give this one. Now after loading the data, you have a data frame B, right? And in this B data frame, we have 2A531 customers, right? And for each of the customer, I have her buying probability, and I have her expected buying amount, right? Okay, so this is our prediction. But in order to do marketing, we want to kind of apply this logic, right? Start with these two things. Okay, it's already in the data frame B, right? Now, the thing is, like, we want to do assumption on the cost effectiveness of this marketing instrument. Okay. Now, usually, well, this could be a little scary. Okay, so the cost effective function with parameter. Say, suppose that this is the effect, right? And this is the cost of the coupon, and this is the effect, right? As I already say that when you apply an instrument, its effect should be on the probability on the money or both, right? So for simplicity, let's suppose that the effect is on the probability, okay? And of course it has effect on both properties, right? But for today's example, I just put the example on the probability effect, okay? And when you learn how to do the things on probability, it's exactly the same things that you want to do it on the buying amounts. It's exactly the same thing, right? So we know that, and let's suppose that our instrument is a coupon, right? It would be a lot easier. So the face value of the coupon would determine, or I should say that the increment of probability, the effect of probability, would depends on the face value of the coupon, right? That it's a reasonable assumption, right? And but however, besides the face value of the coupon, it would also depends on some instrument characteristic, right? And it also depends on some customer characteristics. Okay? It means that when I have the same coupon, it may not have the same effect on every group of people, right? If I send a $10 coupon to like adolescent, that might work, right? So $10 might mean something for younger people, right? But if I send a $10 coupon to like the age group of 35 years old, it will not take effect at all, right? So it's not just the cost that affect the effect, right? The cost and effect would be parameterized by some other parameters, right? That's the, yes.
Professor, but the age group would be the customer's characteristic, like adolescent or adult. But what would be an example of the characteristics of an instrument?
The characteristics of the instruments, yeah, like coupon has some, and if you are sending toy, right? You are sending, if you are using some, you collect point and then you can exchange gift. That is another story, right? And if you're using advertisement, it's another story, right? So these are the difference of the instruments, and there are some factors actually customer dependent. Okay, so we know that there are relationship between effect and cost effectiveness, and the cost effectiveness will depends on some parameters. That is the basic idea about flexible, parameterized assumption. Okay. So the assumption that we are doing is something like this. Okay. We know that for most of the instrument, they have an S-shaped cost-effective function. Okay. No matter which type of instrument you are doing, again, side coupon for example, if your face value is too low, right, it's no effect at all. Okay. Now, in this in the x dimension, we are increasing x, which is the cost of the instrument. You can also say that cost actually imply the intensity of the instrument, right? The intensity of the instrument will like reflect on its cost, right? So if I start to increase the face value of coupon, the probability would start to increase, right? For example, if I do the face value from $0 to $5, when I set the face value from $0 to $5, there will be no effect at all. Okay, and after $5 would increase, the buying probability will increase slowly, right? Okay, and we go to the $10, start to the marginal effect of the intensity start to like speed up, right? And then you go to the middle point, and then but you increase the face value, the probability will increase rapidly, right? But after a while, when you go to like $20, $25, the marginal effects start to diminish, right? This is what we learn in economics, right? Diminishing marginal effect, right? So and after all, it will saturate, right? When you go to the saturated point, you increase the because the probability can be increased only to some limit, right? Okay. After that limit, you will saturate, right? So this is what we mean by S curve. It's not S, it's actually an inverse S, right? But most of the instrument, they have this S-shaped cost-effective function, okay? Be that advertisement, be that coupon, be that discount, whatever instrument you're using, you will actually follow this shape. The cost-effective function will follow this shape, okay? But this S-curve has three parameters, right? First of all is the height of the curve, okay? Which imply the maximum effect of this instrument, okay? And in this case, I set it to 0.2. which means that this coupon, okay, the maximum probability of increment is up to 20, right? No matter how many dollar face value you use, it will saturate at 20, okay? That's the highest point, okay? The second parameter is the B, okay? B is actually, there's a rising slope, right? As you can see that the S-curve has a rising slope. See that? So the center of the rising slope, okay? Which means the position of this S-curve. If the B is like 50, then the S-curve will shift to this way, right? Okay, and then if the V is like 100, it will shift to left, okay? So, cite the coupon for an example. If you are, this could be the S-curve for adolescent, because it would have effect when X is only like $15, right? Now, if you apply the coupon to the age group of 35, okay, for the working age group, okay, this $15 would mean nothing to them, right? Okay, so you can expect that the curve like shift to the right, isn't it? Okay, so you actually B determine the horizontal position of the cost-effective curve, okay? And A is actually the width of the rising slope, okay? Some instrument has a very wide rising slope, okay? Some instrument has a narrow rising slope, okay? So if you know MBA, you know these three parameters, okay? We can draw a cost-effective function, a S-shaped function, only by given MBA, which determine the height, the horizontal position, and the width of the S curve. Okay.
Professor, B is the midpoint.
Right. The midpoint of the rising curve. Okay.
And M is the highest of the rising curve?
Right. M is the height of the S curve. B determines the horizontal position of the S curve. And A represent the width of the rising slope. Okay.
Professor, how would we find these two then?
Well, actually, if you do if you apply this instrument enough of time, you will have some data, right? Then you can use basically some regression technique. Then you can determine the MBA. But we do not have the things, and I do not have the time to do that. So far, we just do it by assumption. Okay, but although it's assumption, we want to emphasize that this is a reasonable assumption, right? Because every instrument will follow this S shape, and it's a flexible assumption. Because MBA is not fixed, right? We let the MBA be parameter in our program, okay? So afterward, we can adjust MBA to emulate different kind of instrument, okay? Or actually, you can put the MBA on different age group, or have a different MBA for the same instrument, isn't it, right? So this is basically what we are going to do today, right? We are doing assumption on the cost effectiveness of marketing instrument, okay? Although we do not have data, we are using a reasonable and flexible assumption on the marketing instrument, so that when we are writing program, we write the program once, okay? But that program can apply to all of the instruments that follow the S-shaped cost-effectiveness curve. And as I say, that most of the instruments, they do follow the S-shaped cost-effective function, right? So, of course, we do not know the reason, the value of MBA for sure, but that's okay. We can make assumption, right? And we can very easily adjust the assumption to see when the assumption change, how our strategy and the corresponding outcome will change with this assumption, right? That's the point of assumption and simulation. Get my point? Problem up to this point of time? Okay? Okay. So let's go back to our code. Now we already have we already have these two things, right? So right now we want to do the assumption, okay? So we can do the calculation. Now let's see, this is the same chart I have explained to you, okay? In R, within R we have a function called P logistic, okay? The P logistic function is actually just S-curve, right? It's exactly the S-curve, right? But you need to shuffle in the MBA, right? To make it to make the MBA the height, the horizontal position, and the width of the S-curve, okay? So its mathematical form is like this, okay? You don't have to worry about it, because I already write a function for you, okay? So I define a function called dp, okay? Stand for delta p, okay? So delta p is the function of x, right? Simply like delta p, right, is the function of x, right? Okay. Delta p is the function of x depending on MBA, right? MBA is the thing that you can specify, okay? You can specify the height, the position, and the width of the S-curve, okay? So as you can see that in R, the code is like very simple, and you can reuse this code, okay? So let's see that if we set m equal to 0.2, b is 30, and a is 40, okay? So, and then we can draw the curve of this dp function, right? So as you can see that the height will be like 20, right? The height is like determined by m, right? So the height is 20. B is 30. So the midpoint of the rising curve is 30, okay? And the width is 40. So the width is something like from 10 to 50, right? You see that, right? So you can very easily change this MBA to change the shape of the S-curve. Do you want to try? So we can try this, right? I simply change the parameter of this dp function. I can change the S-curve, right? For example, if I want to have like 50, right? Okay, and B is like 100, okay, and A is like 60, okay. Can I run it again? Uh-oh, what's the problem? Sorry, I need to adjust the, because right now 0 to like, yeah. M is 50, and B is 100, and A is 60, 0 to 150, 0 to, see, you can see the S curve, right? So, and so basically, if you change the MBA, the S shape will like move the way you like, right? You change the high, maybe to like, so if you want to change the high, then you can like, see, just lower, right? And if I change it to like 70, oh, so you shift to this side, right? If I change it to like 120, shift to that side. You see that? Right? Okay. So there are some implication, right, on the real marketing instrument, right? When you shift to the left, it means that the marketing instrument is cheap, right? When you shift to the left, it means that the instrument is costly, right? Okay. When it is higher, it means that the instrument is very effective. When it is low, it means that the instrument is like less effective, etc. Right? Okay. So the same code can apply to all of the S curves that you can imagine, isn't it? Right? That's true. That's the beauty of programming, right? You write program once, then you can use the program many times. See that? Okay. Okay. So this is basically what we first of all, we determine the cost-effective function, right? Now we know P, now we now have the cost-effective function, right? So, and then we need to calculate the delta P, right? Okay, we still have some time left. So if we know the delta P, now the next thing we want to know is the incremental profit, right? If I can increase the buying probability by delta P, right? Okay. And if that customer's expected buying amount is like M, right? So this would be the incremental revenue, isn't it? This is the buying amount, expected buying amount, right? And this is the increment on buying probability, okay? So the increment of buying probability times the buying amount is the expected increment of buying amount, right? So this is the increment of buying revenue, and you need to multiply it by margin to get profit, right? Right? Okay. So these things are the incremental profit. Okay. If I apply the delta P to the customer, right? But the instrument has a cost, right? So for its next payoff, you need to deduct the cost. Okay? So that's basically the way that we calculate the cost effectiveness of the instrument of cost X and effect delta P. Yes.
Professor, so when you book an Uber, different customers get different coupons. Like the coupons are very specialized. Like if I get 50 NT dollar off, it doesn't mean that my friend will get the same coupon. Even on Uber Eats, we get.
Not necessarily.
Yes.
Not necessarily. Today we are talking about, especially in today's digital marketing, we do have the capability to send a coupon of different face value to different people. Okay? So
Then in this formula, when we have to subtract the cost of X, which will be the cost of the coupon, then do we make a column X? Because different customers might have different face values. So
yes, you can do that. I will cover that later. Okay? That's for now. Let's assume that we are using the same coupon for everyone. Okay? And later on, in the next hour, I will actually cover if we want to do like if we want to apply different instrument or apply the same instrument for different age group, that we can do that. We can do that. Okay. But for now, let's assume that we are applying the same instrument on all of the customers. Okay. So this line is basically how we calculate the cost effectiveness. Okay. But how about this one? Well, when you increase the probability, there will be a problem, right? If the buying probability of this customer is already like 95%, okay? So I cannot increase the probability by 20%, right? So if I already have, if my expected buying probability is already very high, right? Okay, so the probability will be kept at 1, right? Okay, so if I already have a buying probability of 98%, the delta P would not be the delta P in this curve, right? It would only be like 2%, right? It's because that my personal capability would kept my buying probability to 1, right? So for those who like P plus delta P less than 1, it should be this one, right? The otherwise we should calculate the cost effectiveness of the tool in a different way, right? To cope with the problem that the probability would be larger than 1, right? So there is some complication here, but the logic is not difficult to understand, right? Okay. So now we have the assumption on the cost effectiveness. Now we have a way to, like, after knowing that cost effectiveness, we kind of like, we can calculate the net payoff when we apply a specific instrument to all of our customers. What would be the expected net payoff, right? The way we calculate the net payoff. Okay? So Now we can write some program to implement this logic. Okay? Let's take a 10 minutes break. And after that, we will start to do the programming to implement the business logic that we covered in this hour. Okay? Okay, let's be back at 10 after 10.